Greetings and welcome to my new calculus channel. So after I posted this video about a new members channel, somebody really went absolute crazy about asking me what is trigonometry. So, hi man, I'm new. I'm only good at arithmetic. How do I learn trigonometry? He doesn't realize he's not even good at knowing what a number is, never mind arithmetic. But he's in the same boat as so many others. And again, hi man, I'm reading your calculus book, but I don't understand, trying my best. So how do I learn trigonometry? Trigo, he calls it. I know only basic arithmetic. I suspect this person is from somewhere in India. And I bet he doesn't even know that the Indians also made some major contributions to trigonometry. But of course, their educational system is so screwed up. And today, there are not many of them who understand where trigonometry came from, how it developed, and what it's all about. So what I'm going to do in this video is I'm going to talk as long as I can about this and explain to you how to understand trigonometry. So you need to be patient. I might be going on for a little while. Now, the best place that I used to turn to as a youngster was the Encyclopedia Britannica. That's right. I was about 8 or 9 years old when I started reading the Britannica. And it's a great place to start, in my opinion, for somebody who's pretty smart. But I still think that even if you don't know a lot and you're not pretty smart, this is still the best place to come to because it summarizes everything. And not that it's accurate. It has mistakes, and I have found many mistakes, and I'll probably point out some mistakes as I'm going along in this entry. So let's start reading. I'm not going to read everything. I want to point out that this article was written by Raymond Walter Barnard and Eli Maor, for whom I have no respect whatsoever. But it's not a bad article, at any rate. And I'll point out their errors because it's not really the Britannica itself, but these academics have made this contribution, okay? And it says fact checked by the editors of Encyclopedia Britannica. That's quite funny. All right, so it says trigonometry, the branch of mathematics concerned with specific functions of angles and their application to calculations. That's not even 1/6 of what trigonometry is, and it's not really what trigonometry is about. But I'll get to that in a moment. So it says there are 6 functions of an angle commonly used in trigonometry. Well, I don't know that I would call those functions in a primitive sense. They have become functions in an advanced sense. And I'll elaborate a little bit more on that later. So the names of these functions, these have been given special names, and I think the names have changed several times, and I think even the name sign has been influenced by Indian academics. So it says these 6 trigonometric functions in relation to a right angle are displayed in the figure, the ones that you normally learn here. But this is also, again, not entirely true because if you look at where we got the concept of trigonometry, it comes to us from the circle, okay? Trigonometry is just a special kind. It's a special kind of geometry, okay? So let's draw a line here and a line here and a line here. Okay, they're not exactly straight, but that doesn't matter. I'm not going to waste time trying to get the diagrams perfect. So now, what gives rise to trigonometry? Okay, very simply this. It was the desire to be able to take 2 lines, any 2 lines, let's just say any 2 lines like this, or any other 2 lines like that, and try to find a unique measurement that would identify the inclination between these 2 lines. And The ancient Greek word is klisi, okay? I don't know if I spelled it correct. This eta might be here or the I might be here. I've never been to Greek school. That's a K, by the way. And klisi means inclination in Greek. It is the primitive word for inclination. Okay, so in other words, the Greeks imagined a horizontal line which just stayed the same and was lifted upwards. Here's the same line upwards, same line upwards, same line upwards, etc. How is this possible? It's only possible with a circle, okay? So you begin here, then here, then here, then here, etc. Okay? So that is why trigonometry started with the circle, and they had to figure out a way to measure these angles. Okay. And the way they did that was they used chords. Now, in my special knowledge, which I revealed recently, which I wasn't going to, but I have, it's called Ancient Greek Trigonometric Formulas. I show you how you can move away from radian and degree measure entirely. In other words, the only aspect of the circle that you carry through to my kind of measure, which is radical unit angle measure, is the fact that you're using this line here, okay? So you're no longer using the chord as one of the first Greek mathematicians did. Just can't remember his name right now. I think it sounds something like hippo, okay? All right. Anyway, so what he did was he tried to figure out this angle in terms of this line with its relation to the circle radii. All right. So trigonometry, I'll come back to all this in a moment. Trigonometry is, in fact, a derivative it is an offspring of geometry, totally of geometry. And the Britannica article that I'm reading to you now, in fact, agrees with that. Okay. So it says, but here's the first big mistake, and it's not a surprising mistake. It says, uh, trigonometry developed from a need. Well, this isn't a mistake, but I'll get to it in a short while. It says trigonometry developed from a need to compute angles and distances in such fields as astronomy, map making, blah 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 blah, and then it says it goes through the word the definition of the word. So let's look at the definition of the word quickly. Let's clear this out. And I think it's important for you to know the word. So the Greek word, and if I've spelled it correctly, because my Greek spelling is atrocious, trigonometria. Now, I don't know if these are O's or one of them is omega. It doesn't matter anyway. In fact, I can quickly check, by the way. I don't have to be good anymore because I can just come over here, go to translate, and I choose Greek, and I turn on my microphone. Trigonometria. Okay, so yes, I made one mistake. There's an omega over here. Okay, so this one here is an omega, but that's because of the weird nature of Greek, the weird nature of Greek grammar. So this here would be an omega. By the way, an omega and omicron make exactly the same sounds. Okay, and I have no idea why they use two different letters for the same sound. But I can give you many examples. For example, all of these E, 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 all of these make the same sound E. Even this E makes the same sound, okay? And uh, these here are called diphthongs. I don't know much about Greek grammar since I've never been to school. But anyway, the correct word, there's your Greek lesson from me. I'm not interested in teaching you Greek, so let's clear the board here. So let's go back to the the meaning of where trigonometry came from. So trigono, and I'll probably write it correctly now because now the emphasis is on here, on this syllable here, trigono, okay? Trigono, that's a row or an R. Trigono and metro. Okay, now the word metro, and I don't know if this is an O or an omega, but let's say omega, metro. Anyway, trigono means triangle, and metro uh, is a form of measure. It means measure. It can mean count. It can mean measure. Okay, it can mean several other things, but in the elements of Euclid, words that are derivatives of this and similar words are mentioned hundreds of times. Okay, it's all about measure. And the chief, but there I'm going off on a tangent again. I have so many things I can say that it's hard to speak about the same subject. But anyway, so the word trigonometry comes from a combination of this word and measure. In fact, another Greek word is metrisis. Okay, metrisis, and I don't know if I wrote that down right. Metrisis. That means measurement. That also appears many times in the elements. So it's a combination of these two words, okay? Trigono and measure. A triangle and measure. So triangle plus measure is trigonometry. Excuse my writing. Triangle plus measure is trigonometry. Okay, now let's go back to my Britannica article and continue to read. So it says until about the 16th century, it was chiefly concerned with computing the numerical values of the missing parts of a triangle. Um, okay, never mind. I don't want to go for a tangent again. But the first mistake comes up here. It says such calculations distinguish trigonometry from geometry, which mainly investigates qualitative relations. That's absolute BS, okay, because geometry does not only investigate qualitative relations, but it is the foundation and the basis from which you get the concept of number, okay? So it starts off with qualitative comparisons, which end up being ratios, and then the measure of those ratios, the measure of the ratios leads to numbers. This is something that I, the great John Gabriel, have revealed to the world. Okay. And I've written an entire book called The Ultimate Book of Numbers, which is free. It's on academia. You can get it. So these fools who wrote this article, and just let's remind ourselves who they are. Two blundering idiots, Raymond Walter Barnard and Eli Maor. The second one sounds like a Jew name. Okay, anyway, that is 100% wrong. Such calculations distinguish, there is no distinguishment. Trigonometry is geometry, 100% geometry. Okay, there is no difference in the two. Trigonometry is circular geometry. Do you understand that? It comes from the circle. It derives from a quarter of a circle, which forms the foundation of circular measure. So the Greeks obviously were trying to find a unique way of in the circle, measuring the angles. Okay. And one unique way was to say, okay, if we have an angle like that, then perhaps the ratio of this the ratio of this distance to the radius, okay, so this distance to the radius, so we'd have this ratio, okay, so this ratio this line, this red line corresponding to this line, and this green line to this green line, represents, provides a unique representation of this angle, okay? This angle here. So that's why you cannot divorce trigonometry from geometry. That's why you cannot do what two young American ladies did in a southern school where they thought they had found a new proof. Actually, they're quite bright ladies, but they didn't really discover anything new. So I'll come back to this in a moment. Now, um, this is all about trigonometry and where it comes from. And we know that geometry is about qualitative and quantitative. And in fact, geometry builds up all the theory that leads to numbers. So the first 6 books of Euclid are a prelude. And in fact, there's another prelude to that, which is also a universally misunderstood concept. There are no axioms in mathematics. And all the 5 requirements that are usually referred to as axioms are not axioms, but are derivable systematically and validly from nothing. And I also proved that in my article called There Are No Axioms or Postulates in Mathematics. I've written thousands of articles on academia. This is the site, and they're all free. What you should do if you want to become a genius like me is to read these articles and study them carefully. You can't browse through them. You have to study them. Okay, there are many articles here. It just goes on and on and on. I've written over 272 papers, which are free. Several books. It says 1 book here, but I've written about 3 or 4 books already. And I'm going to be starting a new members channel in which I will share knowledge I've never shared with the world or humanity. But you'll have to pay for it. It's going to cost you €5 a month. And I'm only going to start after I have at least 100 subscribers, which means I need an extra income of about another €500 a month in order to be able to get off the poverty line and live comfortably. Well, not comfortably, but get out of survival mode, which is what I'm in right now. I'm in survival mode right now. I don't get a big pension. You'll be shocked to know that I get less than €1,000 a month as a pension. And I was actually cheated out of my Social Security because there's a rule in Social Security that when you become disabled, you need a certain amount of recent work credits. It's entirely evil and brutal and wretched. And I really should have been getting a lot more because I've paid more taxes than most people would pay their entire lives. But anyway, that's how the system is. It's unfair. I don't have money to go to a lawyer, and lawyers are themselves a bunch of sharks. But there again, I'm going off on a tangent here. Let me get back to the article. So it says here, this part here is discussing the origin. So that's the first big mistake. Okay, geometry is not just about qualitative relations. It's these two idiots here are, of course, idiots and have a very superficial understanding. If I click on this guy, he's an associate professor of mathematics at the University of Chicago, and this guy's another idiot, adjunct professor of mathematics at the University of Chicago, Illinois. Both of them are idiots. No surprise there. Okay, let's go down after I've completed my insulting. Now, then it starts about the ancient and the Mediterranean world. So just a load of crap here because I mean history is really written by humans and there are a lot of mistakes and talks about the Egyptian Sekhet, which is so here's what here's what comes to mind when I read this. It says the Egyptians defined Sekhet as a ratio of run to rise. Now, what does ratio of run to rise mean? Okay, so if you have something like this, we normally talk about this as the run and this is the rise. And Newton and all the others understood the incline of this line here, to be expressed as rise over run. Okay. But the Egyptians thought of it as run over rise, not run over rise. In fact, both of these are wrong. Let me just make some space here. Not wrong, they're just misunderstandings. So a ratio, by the way, is not written like this. It's not written like this. Okay. Not written like this or like this. But modern mathematics professors are idiots who don't understand number or ratio. So if we write rise to run, that's the ratio, okay? If we were able to find a common denominator of rise and run, then we could say that the measure of this ratio, is equal to rise over run. So for example, if we had integers here, let's say 2 to 3, then we could say that the measure of this ratio is equal to 2 over 3, okay? Because 2 over 3 does not mean the same as the ratio 2 to 3, okay? Just as 4 to 6 does not mean 4 over 6. The measure is expressed as 4 over 6. This is a very subtle understanding and nuance of numbers, which the morons of mainstream mathematics do not understand, have never understood, and refuse to understand because they are a cabal of idiots. So let's get back to the video. These things are very important, by the way. So when we look at the article, this here is just a bunch of crap which is irrelevant, has very little really to do with the subject of trigonometry, because it tries to uh, infer that algebra solves this problem. It doesn't. There is no way to express many angles in algebra except as a ratio. Okay, so trigonometry in the modern sense. Oh, here's the guy I was looking for, Hipparchus. He was the one who I mentioned earlier when I drew the circle like that, and I did this, and I said this. He wanted to use the chord and the radii. Okay, that was the guy I meant earlier. All right, let me see if I can speed up a little bit. So he considered every triangle planar or spherical. I'm not even going to go down that line. It's just a bunch of crap. But anyway, let's leave that as it is. And so we've got some more text here which talks about astronomy and other sciences. Okay, so finally we get down to the first major ancient work, which are these, which is a work of Hipparchus, where it says that C, this line C, is equal to 2r times uh, half this angle A. So if you were to say, let's just get this here. Let's just pick this up. This is how we find that. This is how we find that. Let's go to the article here, clean this out, paste this over here, paste. Okay, so if we draw a straight line here, then we've halved this angle, so we're looking at A over 2, right? And from the sine ratio is this length over this length. Okay, so it would be C. So it would be C, not A over 2 equals to C. Sine of A over 2 will equal to C over R. Okay, sine of A will equal to half C because this whole thing here is C and this here is half C. So it's C over 2R is equal to sine 2A, which means C is equal to 2R. This is 2R times sine of A over 2. Okay, so that basically tells you why C is equal to 2R times sine A over 2. And sine is just a ratio, by the way. We're assuming that you can write C over 2R. But C over 2R is actually a measure, is a representation of the measure of the ratio of C to 2R, which is totally a different thing, okay? So this ratio is not the same as its measure. And just to give you another example while I'm on this topic, if we take the length of a circle, say that is its circumference, and this is its diameter, that's the ratio. That's the ratio of the circle's circumference to diameter. But if we want to write its measure, okay, measure means we need to measure this black line with this red line, okay? or in more simple mathematical understanding, we need to find something that divides this red line and also divides the black line. And then we can count these guys up and count these guys up and write it as a number. Okay. We can't actually do this. This isn't the measure. Neither is this or this. Okay. This is not the measure. This is not the measure. This is not the measure. This ratio has no measure, you morons. Okay. And it doesn't matter what power series you use or which famous Madhava formula you used or whatnot, you cannot measure this ratio. And there are many such ratios in mathematics. Okay. So it's not got nothing to do with qualitative or quantitative because both of those are geometric. And these two stupids who wrote this article don't understand that. So now, then it carries on continually and into India and the Islamic world and gives us some background on how the Indians shortened the chord and began to call it Jia or Jiva, and just more history, which, by the way, history is written by humans, so it doesn't follow automatically that history is always correct or true. Okay, it's taken as factual, but it may not be factual. Right. Then it discusses the passage to Europe, and then finally it gets to modern trigonometry, which is really just ancient trigonometry with different terms, discusses mathematicians such as Francis Vieta, and introduces the bullshit of complex numbers, which really is not needed, not even in electrical engineering or any other field of science. Continues to talk about how Newton developed his famous trigonometric series. And by the way, uh, what Newton did here is nothing compared to what I revealed in my article here. So if you go down to my webpage and you look for this article here, but of course you need a lot of previous knowledge before you're able to understand this. It's called, what is it called? Um, there's an easier way to do this. Hang on a second. Instead of wasting time, come on, downloads, go to this guy and look for ancient Greek. I've written so many articles, I don't even remember. Okay, so this article here that you see here, ancient Greek trigonometric formulas, they're not really ancient Greek. They're actually John Gabriel formulas, are exact formulas. And they make Newton look like a fool or a little kid because they're closed form. Do you know what closed form means? Most of you don't. But those of you who have a BSc or a master's can study this article and get a little glimpse into my genius. You fucking morons. Professors, I'm addressing, by the way, not the rest of you. I'm addressing the vile scum who have been persecuting me all these decades. Professors of mathematics and the mainstream mathematics academia. In this article, you'll get a glimpse into my genius, okay? And of course, you need some background. In other words, you need to have studied this when you were 8 years old or 9 years old, which is what I did. Okay, this has been, of course, this may have been updated, but it's been around a long time, this knowledge. So these little so-called series, they're not infinite, by the way. This dot, dot, dot doesn't make them infinite. It's just a finite number of terms with an ellipsis. There is no such thing as an infinite series. It's a garbage concept from the beginning right through to the end. It is absolute rot. Okay. And so, yes, so it continues now into more bullshit like the Moivre's theorem, which uses fake algebra, which, by the way, comes to you directly also from geometry. So what is the main difference between algebra and geometry? Simply this. Simply this. In geometry, measure is 100% precise, okay? In other words, if you want to do any of the basic operations of the arithmetic, the answer is always 100% accurate. In algebra, it's not. And the reason for this is that geometry uses the physical unit, a physical unit, uses a physical unit, okay? And or parts of the physical unit, okay? Very important in the understanding of number also. And of course, algebra sacrifices precision for generality because it uses an abstract unit. Now, listen carefully. And or not parts of it, but equal parts. Okay, equal parts. Remember what I showed you earlier about the ratio of the circle to its diameter? You need to find something that measures these exactly. And then you count them up, okay? Then you count them up and you have the measure of a circle. 159, approximately, by the way. It's not equal to that. It's approximately equal to this. All right? So that is the main difference between geometry and algebra. Algebra is a weaker form of geometry. That's why you can end up with mistakes such as x over 0 or 0 over x. 0 is not a number. It's very useful, but it's not a number. And the reason there are so many mistakes in algebra is due to the fact that bullshit professors, mainstream professors and teachers who are idiots, don't understand the concept of number, okay, and don't understand algebra and a lot of other things. But never mind, I've discussed much of that in my video, so I'm not going to waste time on it. And so the article gets into complex numbers and complex use of complex numbers in trigonometry. Now, the most useful parts of trigonometry, by the way, in physics, don't have anything to do with complex numbers. And so these fools here try to say that a vector needs trigonometry, needs complex numbers. It doesn't. The components of a vector can be stated without using complex numbers whatsoever. Okay. So, and then they have a section here where they begin to talk about vectors, and it says a somewhat more general concept of an angle is required for trigonometry than geometry. That's absolute rot. What does that mean? A somewhat more general concept of angle. What absolute crap. I mean, please do read this article if you're a professor of mathematics, because you're a moron and you need to read it and understand it. Okay, you're an idiot. And I repeat, you're an idiot. You're not bright and you're no mathematician. Please, if you have a PhD, do not call yourself a mathematician because your PhD is not worth shit. Do you understand that? Okay, now, an angle A with vertex at V, with the initial side at VP, and the terminal side is indicated by the figure. So basically, this here is just absolute garbage, which will mislead people who read it for the first time. I mean, a student reads this is not going to even understand what these people are trying to say, which, to be honest with you, is absolute crap because a vector doesn't replace angles. In fact, it uses angles, okay, entirely. And you can't have notions such as clockwise and anti-clockwise if you don't have angles. But the two guys who wrote this article are obviously morons, so we have to bear that in mind. Now, you can carry on reading the entire article. I don't have time for it. I think I've gone on for quite a while. There's nothing really earth-shattering or, how can I say, important in this whole article of Britannica. But if you want to know what mainstream mathematicians think, then you should read this article, because then you'll know exactly what they imagine to be trigonometry. and number and algebra and geometry. It's all wrong, but you still need to know it, because the best way to fight your enemy is to know what they think. Okay? So if you don't know how your enemy thinks, you can't fight them properly, which is kind of ironic because fools out there have said that I don't understand what I'm talking about and that the mainstream mathematicians have pointed out my errors. The truth of the matter is that it's the other way around. And I have taken the trouble to find out what they think about things. In fact, I was as young as 8 or 9 years old when I began to read the Encyclopedia Britannica. So, just to summarize, trigonometry is just a special subset of geometry in which we uh, take the concepts of geometry to help us perform measures that relate to the world around us. Okay, in other words, astronomy, uh, and all the other architectural scientific fields where we need to, engineering, scientific, architectural, where we need to use measure to arrive at useful results. Which, by the way, if you're smart, you'll notice I used the word measure a lot, because mathematics is the abstract science of measure and number, not the bullshit that Marcus Clivers or Zeller Malums or Jean-Pierre Massages or Professor Jack Hazingers or Professor Gilbert Strangs or any one of those morons think. It's what I told you. Mathematics is only the abstract science of measure and number, nothing else. Set theory is not mathematics. Topology is not mathematics. A lot of the bullshit you do past a BSc course at university, and even in a BSc course in university, is not mathematics. It's part of the cabal's cling to power. They don't care about you. They don't care that they're wrong. They don't even care that the new calculus is 100% rigorous. All they care about is trying to look erudite and smart, but they're a bunch of fucking morons. If you're not already a subscriber to my channel, become one. Follow me on academia. Don't believe a single word I say, you idiot. Study my work, and then you'll know that what I'm telling you is true, because I know what I'm talking about, and your math professor and your math teacher are a bunch of idiots and knuckleheads compared to my intelligence. Now, if you want to become a member of this channel, you need to pay €5 per month. And I'll reveal a lot more, by the way, and I'll go through these concepts step by step beautifully, okay? Explaining everything in the right chronological order, and building each concept and each theory on prior concepts, not like you find in your high school and university courses, where suddenly you're confronted with a concept that you have no clue about simply because your moron teacher doesn't understand where it came from. Okay. I have many other things to say, but I'm actually out of breath. And this is a favor to this guy here who kept on bugging me. By now, you'll have a good idea of where trigonometry came from, but you need to do a lot more studying. I mean, you seriously need several months, probably years, to even get to the point where you can understand what I've discussed in this article in full. But now you have in your subconscious these ideas, and each time when you encounter them, it's not as if you have a blank slate where you can acquire knowledge uh, without inference. Here you'll have knowledge acquisition through inferential suspension. CATUS, that's my theory of learning. I'm John Gabriel. This is the New Calculus channel. And if you think you're smarter than me, you're a fucking idiot. Goodbye.